The purpose of this channel is to help you understand the concepts of physics. I have made it very simple, so anyone can easily follow these lessons. Let's get on with today's lesson. In this video, we are going to look at questions related to motion in a straight line. Please check my previous video to understand the kinematic equations applied to an object moving in a straight line. Let's review what we studied in the previous video before we get on with today's exercises. We defined velocity as the rate of change of displacement and acceleration as the rate of change of velocity. Both of these expressions are shown on the screen. We derived these four equations in the previous lesson. These are known as Suvit equations. S for displacement, U for initial velocity, V for velocity after time t, A for acceleration and t for time. S, U, V, and A are vectors, but t is a scalar quantity. You can use these two triangles to remind the relationships between displacement, velocity, acceleration, and time. I have shown the expressions next to each parameter. If you refer to the first triangle, velocity is equal to displacement over time. But if you use the second triangle, velocity is equal to the product of time and acceleration. I hope you understand how to use these two triangles. This will come in handy when you need to find a variable, when the other two variables are given. Let's get on with the exercises. A vehicle moves with a uniform acceleration of 1 meter per second per second. This vehicle travels 42 meters in 6 seconds. Calculate the initial and final velocities of the vehicle. We can solve this problem using the Suvit equations that we saw in this video earlier. But let's use a velocity time graph to solve the problem. Let's take U as the initial velocity. Next, we draw a line with a gradient of 1 meter per second per second. We can calculate the change in velocity by taking the gradient of the line and time. This is shown in the graph as 6 meters per second. Now we can calculate the final velocity by adding the initial velocity U to the calculated velocity. This is shown in the graph. The displacement of the vehicle is given by the area under the curve. We can write an expression for the displacement using the formula that we derived for the final velocity and U. This is shown on the screen. We can substitute the values for each parameter, as shown on the screen. Now make U the subject, and solve the expression to arrive at a value for U. Using this expression, we can find the value for the final velocity. Substitute the value for U, and calculate the value for the final velocity. I hope this explanation was clear. Let's look at the next problem. A vehicle travels with an initial velocity of 5 meters per second. It travels a distance of 104 meters in 8 seconds. What is the velocity of the vehicle after 8 seconds? We will use Suvit equations to solve the problem. Let's list down the Suvit values. The displacement of the vehicle is given as 104 meters, and the initial velocity is given as 5 meters per second. We need to calculate the velocity after 8 seconds. However, we do not know the acceleration. We can use this equation to find the value of velocity after time t. This equation does not have acceleration as a variable. We get the velocity after 8 seconds when we solve this equation. Let's solve another similar problem. A boy throws a ball with a velocity of 10 meters per second. It travels with a deceleration of 5 meters per second per second. How far did the ball go, and for how long did it travel? Let's solve this problem using a velocity time graph. The ball should come to rest when its velocity reaches 0. Let's sketch the movement of the ball in a velocity time graph. We can calculate the time when we take the ratio of velocity to acceleration. This will give the time taken for the ball to come to rest as 2 seconds. The displacement of the ball is given by the area under the curve, which is 10 meters. Let's use Suvit equations to solve this problem. First, list down the Suvit values. We need to find the displacement. The ball is thrown with a velocity of 10 meters per second. Therefore, the initial velocity u is equal to 10 meters per second. The final velocity of the ball is 0. Because the ball reaches its maximum displacement when the velocity is 0. The deceleration is given as -5 meters per second. We need to find the time taken to reach the maximum displacement. We can use this kinematic equation, which has displacement as a parameter. The displacement of the vehicle is given as 10 meters. Let's use this equation to find the time taken to reach the maximum displacement. I prefer to use this equation because it does not have any of the values that we calculated before. If possible, try to avoid equations or formulas that require pre-calculated values. The time required for the total displacement is 2 seconds. Let's look at the next exercise. A boy goes to school on a bicycle at a speed of 12 meters per second. He returns home with a speed of 24 meters per second. The school is 72 meters away from home. What is the average speed of the boy? Let's draw a velocity time graph to show the movement of the boy. I have used 2 quadrants to show the outbound and inbound movements of the rider. The area under these 2 curves is equal to 72 meters, since the boy is riding the same distance, back and forth. However, the time taken for each trip is different, because the speeds of outbound and inbound are different. We can calculate the time taken for each trip by taking the product of the area under the curve and the speed of the bicycle. Now we can calculate the total time taken for outbound and inbound, which is given by this expression. The total distance traveled is the sum of outbound and inbound. Now we can calculate the average speed of the vehicle. This is given by the ratio of total distance to total time. Let's look at the next exercise. A vehicle starts a journey from rest and reaches a velocity of 16 meters per second. It continues to move at the same velocity for 2 seconds before it comes to rest. The distance traveled with constant velocity is the same as the distance traveled during deceleration. The magnitude of acceleration is twice the magnitude of deceleration. Calculate the total time and distance traveled. Let's draw a velocity time graph. We do not have all the information to draw a complete graph. But let's use the available information to do a sketch as shown on the screen. The distance traveled with a constant velocity is the same as the distance traveled with deceleration. Therefore, area A2 is equal to area A3. If we take t of d as the time taken to decelerate, then we can write an expression for areas A2 and A3 with time t of d, which is shown on the screen. When we solve this expression, we can calculate the time taken to decelerate. Next, we need to calculate the deceleration in order to calculate the acceleration. The deceleration is given by the gradient of the line CD. The magnitude of acceleration is twice as great as the magnitude of deceleration. Therefore, acceleration is 8 meters per second. We can calculate the time taken to accelerate from this expression. The total time is the sum of t of a, 2 seconds, and t of d, which is 8 seconds. The distance traveled is equal to the area under the curve, which is the sum of area A1, area A2 and area A3. The total displacement of the vehicle is 80 meters. Let's move on to the next problem. An object has an initial velocity of 24 meters per second. It has a constant acceleration of 6 meters per second, in the opposite direction of the velocity. Calculate the time, when the displacement of the object is 21 meters. Let's understand the direction of the displacement, velocity, and acceleration vectors of the object. The initial velocity of the object is in the upward direction. The movement of the object is in the same direction as its velocity. But the object decelerates at a rate of 6 meters per second. The object will move in this direction until its velocity is 0. At this point, the velocity of the object is 0. But the acceleration remains at 6 meters per second, in the downward direction. The object starts to move in the opposite direction from rest, but with an acceleration of 6 meters per second. Velocity increases as it moves in the opposite direction. It reaches the initial point, and the magnitude of the velocity is the same as the starting velocity. The object will move in this direction, with an acceleration of 6 meters per second. The object crosses the 21 meters displacement twice. Therefore, we need to find both of these instances in time. Let's list down the Suvit values. We need to calculate the time, when the displacement is 21 meters. Therefore, we can take displacement s as 21 meters. The initial velocity is given as 24 meters per second. We do not know the velocity, when the displacement is 21 meters. The acceleration of the object is given as 6 meters per second. But it's in the opposite direction to velocity. Therefore, acceleration is minus 6 meters per second. We need to calculate the time. We need to select an equation that does not have the final velocity as a parameter. Let's use this Suvit equation to calculate the time, when the displacement is 21 meters. We can substitute the given values in this equation. We can derive this expression, which is a function of t. We can write this expression as a multiple of factors. We get these two values for t when we solve for factors. This gives the instances in time where the displacement of the object is 21 meters. Let's look at another problem. Object A travels with a constant velocity of 32 meters per second. Object B starts to move from rest with a constant acceleration of 16 meters per second as soon as object A passes object B. Find the time taken for object B to overtake object A. The displacement of these two objects is shown in a velocity time graph. When object B overtakes object A, the displacement of both objects is the same. Let's take t as the time taken by both of these objects for a displacement of s. We can derive a formula for the displacement of both objects by taking the area under each curve. We get two values for t when we solve the expression. T equals 0 seconds refers to the initial position, and t equals 4 seconds refers to the final position. Therefore, object B overtakes object A after 4 seconds. Let's move on to the next problem. Two vehicles, A and B, move in the same direction. When they start the journey, vehicle A is 20 meters behind vehicle B. Vehicle A moves with a velocity of 20 meters per second, and vehicle B moves with a velocity of 10 meters per second. At what instant in time does vehicle A overtake vehicle B? Let's draw a displacement time graph and solve the problem. At time t equals 0, vehicle A is 20 meters behind vehicle B. This is shown on the graph, in the negative y direction. The velocity of vehicle A is 20 meters per second. Therefore, the gradient of line A is 20 meters per second. The velocity of vehicle B is 10 meters per second. Therefore, the gradient of line B is 10 meters per second. Both of these lines cross when time is equal to t. This is shown on the graph. This is the time when vehicle A overtakes vehicle B. We can write an expression for the displacements of vehicles A and B when time is equal to t. We can find the time taken by vehicle A to overtake vehicle B when we solve this expression for t. Let's look at another problem. Two vehicles, A and B, move in the same direction. Both vehicles start at rest. However, vehicle A is 60 meters behind vehicle B when they start the journey. Vehicle B moves with an acceleration of 8 meters per second for 3 seconds and maintains a constant velocity thereafter. Vehicle A moves with an acceleration of 20 meters per second for 2 seconds. Vehicle A maintains a constant velocity for 2 seconds until it overtakes vehicle B. Find the time taken to overtake vehicle B. Let's draw a velocity time graph for the movement of the two vehicles. We can calculate the constant velocities of each vehicle, as shown on the screen. Let's take t as the time taken by vehicle A to overtake vehicle B. We can calculate the distance traveled by each vehicle by taking the area under each curve. The distance traveled by vehicle A is given by this expression, which is a function of time. Let's call it S of A. In the same manner, we can calculate the distance traveled by vehicle B, which is given by this expression, which is a function of time. Let's call it S of B. The distance traveled by vehicle A is 60 meters more than the distance traveled by vehicle B. Therefore, we can write an expression for the displacement of the two vehicles, as shown on the screen. We derive two expressions with time t for the displacement of the two vehicles. We get this expression when we substitute those two equations. This is a function of time. We can find the time taken to overtake vehicle B when we solve this function, which is 4 seconds. Let's look at the next exercise. A boy standing on a lift throws a ball upward with a velocity of 35 meters per second. This ball moves with a constant deceleration of 10 meters per second due to gravity. If the lift is moving upward with a velocity of 5 meters per second, how long does it take for the boy to catch the ball? What is the maximum height that the ball will reach, and what is the maximum gap between the ball and the lift? Both the ball and the lift are moving in the same direction. However, the ball is thrown with a velocity of 35 meters per second. This is relative to the motion of the lift. The boy is inside the lift when he catches the ball. Therefore, we can disregard the motion of the lift when we calculate the time taken to catch the ball. The displacement of the ball is 0 when the ball is in the boy's hand. We can use this kinematic equation to calculate the time taken for the boy to catch the ball. We will substitute 0 for the displacement of the ball. We get two values for time. But the time cannot be 0. Therefore, it takes 7 seconds for the boy to catch the ball. Let's calculate the maximum height that the ball will reach. The velocity of the ball relative to a point on the ground is 40 meters per second. The ball will reach its maximum height when the velocity is 0. We can use this kinematic equation to calculate the maximum height. This expression will give the maximum height as 80 meters. This is relative to a point on the ground. We need to calculate the height of the ball relative to the lift in order to know the maximum gap between the ball and the lift. The maximum gap occurs when the velocity of the ball is 0 relative to the movement of the lift. The velocity of the ball, relative to the lift, is 35 meters per second. The velocity of the ball is 0, at the maximum gap, between the ball and the lift. We can use this kinematic equation, to find the maximum gap. The maximum gap, between the ball and the lift is 61.25 meters. I hope the answer was clear. In the next lesson, we will discuss the motion of an object, under gravity. Please subscribe to this channel, that will encourage me to make more and more videos on this subject. If you found this lesson useful, please leave a comment below. Please don't forget to press the bell icon, before you move out of this channel. Let's meet again with another video. Bye.